Recent advancements in military technology have been nothing short of spectacular. Innovations that only once lived in the realms of sci-fi are now becoming a part of our world. Today on Boost, we dive into the bold venture of the U.S. military, the railgun. But it's not just the U.S. that works on railgun technology. Other nations such as China and Japan are also working on their own weapons of the future. But who is leading the race? Let's find out. Imagine a machine that can shoot objects at mind-blowing speeds without any additional costs. That's the railgun for you, a weapon that uses the force of kinetic energy. In action, it propels a metal object along a path framed by two electrified rails, reaching velocities up to 7 times the speed of sound. This powerful weapon can strike targets more than 125 miles away, shattering the range limits of conventional firearms by over 10-fold. The concept isn't new. It traces back to the late 1800s when an innovative American engineer suggested using a railgun to attack Havana from Florida during the Spanish-American War. Then, in 1917, a French inventor created a small working model for the first time. Fast forward to 1978. The Pentagon initiated a modern railgun program to match up against the Soviet Union's advancements. Years of relentless research and testing, surpassing 1,000 trials, led U.S. engineers to monumental successes in both technology and engineering, significantly extending the weapon's reach. In a groundbreaking move in 2006, BAE Systems was chosen to create a 32 megajoule test launcher for the Navy, marking a significant leap forward in railgun development. Back in February 2012, during an initial phase of the Navy's cutting-edge naval prototype program, a groundbreaking test of the BAE Systems EM railgun prototype took place, showcasing its potential at significant energy levels. The test rig, capable of using 32 megajoules of energy, launched a projectile, but only using half of its power capacity. Further trials of this innovative weapon kicked off in 2014, leading to its first public appearance at the U.S. Navy's Future Force Science and Technology exhibit in Washington, D.C. By February 2015, however, the full-scale development of the railgun was still a few years off, with sea trials pending to understand how elements like salty seawater might impact its operation, not to mention its performance in actual combat scenarios. Throughout its development, the project has cost around $500 million. This project hints at the possibility of developing highly efficient weapons at costs significantly lower than those associated with advanced missiles and smart bombs. The railgun essentially functions as an incredibly powerful electric circuit, consisting of 3 core elements: a power source, conductor rails, and a movable bridge, also made of conductive metals, located between the rails on which the projectile is set. Constructed from materials such as copper, these rails are energized by an immense power output from a generator, creating a positive and negative electric flow that propels a projectile with incredible speed and force, thanks to magnetic propulsion. Supporters of the railgun technology highlight several advantages, including the enhanced safety of vessels by eliminating the need for explosive ammunition, its fast response time for a single shot, and the precision of its targeting based on specific calculations. Yet the railgun faces certain challenges, notably the large size, alongside the substantial power source required for its operation. But something that requires almost no power is clicking the like button and subscribing to Boost for more awesome videos. To generate the necessary force, railguns draw on a huge electric current, sometimes reaching up to 1,000,000 amperes. This current propels a projectile along the rails until it's launched through the muzzle, at which point the electrical circuit is interrupted, halting the current flow. This method of operation is not only costly, but also demands considerable time to recharge for a single shot. Modern railguns can launch a projectile weighing 35 pounds at speeds close to Mach 6, while weapons capable of Mach 8 are coming in the future. The main benefits of these projectiles include their ease of transport, absence of explosion risk, and straightforward production process, essentially requiring just a metal object. One might consider about the effectiveness of a projectile that doesn't explode. The reality is, at speeds reaching Mach 8, even a basic metal object can create an explosive impact upon collision. This indicates that for railguns to be more effective, further improvements in the acceleration mechanism are necessary. Currently, operating such a weapon demands 32 megajoules of energy for each shot, and sustaining 10 shots a minute would use up to 20 megawatts of power. Currently, the vessels in the Navy equipped to supply such immense power are limited to the 11 nuclear-powered aircraft carriers and the 3 Zumwalt-class destroyers, which are designed to accommodate future energy-intensive systems. There was discussion a few years back about mounting such a cannon on the USS Lyndon B. Johnson, one of the newest stealth destroyers. While traditional high-power cannons may be used around 600 times before requiring barrel maintenance, railguns need replacing after just 12 to 24 uses due to the extreme heat and electrical pressure, which can cause the barrel to deform. To maintain a consistent firing rate, the development of durable metals and advanced cooling techniques is critical. Future innovations will also need to address the power and trigger systems to manage the substantial energy expenditure effectively. The Naval Research Office granted BAE Systems a contract worth $34.5 million, with the primary objective of improving the railgun's launcher and power systems to enable multiple firings from a single charge. This contract also covers the creation of systems for automatic reloading and managing the weapon's temperature. GAEMS has already put together 2 railguns and a launcher capable of handling 32 megajoules of energy for this project. GAEMS has also been responsible for the development of the power management systems for these weapons and is in the process of creating specialized projectiles intended for both air defense and precision strikes. The Navy is keen on utilizing railgun technology to defend against ultra-fast missiles, which traditional defense systems struggle to intercept due to their speed and unpredictable flight paths. Railguns have the potential to effectively neutralize incoming hypersonic threats by either damaging them enough to render them inoperative or completely destroying them mid-air. Outside of military use, NASA is exploring the possibility of using railguns as a method for launching payloads into space from high-altitude platforms, although the intense forces involved restrict this application to the most durable materials. This concept also extends to theoretical applications such as launching materials from the moon, where the lower gravity and lack of atmosphere could allow a railgun to propel objects into space at speeds surpassing 5,300 miles per hour, significantly faster than the speed of sound on Earth. The full potential of railgun technology remains to be unlocked, pending further advancements in its design and capabilities. Initially planned for deployment in 2025, the Railgun project was halted by the Navy in the summer of 2021, following a period of reduced funding. This decision was influenced by several factors, including financial limitations and the project's inability to overcome technical hurdles, particularly the rapid deterioration of the railgun's barrel after just 20 uses. The Pentagon also expressed concerns that even with the railgun's capabilities, U.S. naval forces could still be vulnerable to attacks from nations possessing sophisticated missile systems, notably China. But experts still think that railgun technology will be important in the future and expect the program to continue later. China has been investigating railgun technology since 2008, and Japan began showing interest in 2015. That year in Tokyo, they unveiled a model railgun in budget proposals and strategic military documents. By 2016, Japan had successfully tested a railgun that launched a projectile at speeds up to 4,500 miles per hour, positioning it as a potential countermeasure to American advancements. In a landmark test in 2018, China became the first country to test a railgun at sea, launching a 55-pound projectile at Mach 7.3 over a distance of 155 miles. China's military has also conducted tests on a railgun mounted on a ground vehicle, achieving significant progress in essential technological aspects. Also, Chinese researchers are working on hypersonic missiles compatible with railgun launch mechanisms for rapid target acquisition. The Chinese Navy believes railguns could significantly enhance coastal defense capabilities thanks to their exceptional range. In developing their railgun, Chinese experts have drawn upon both their own innovations and those from American research. Details regarding the Chinese railgun's firing capabilities, rate of fire, and specific operational uses remain uncertain. But what do you think? Are railguns part of the future or just a waste of time? Let me know in the comments below. If you found this video interesting, make sure to subscribe to Boost for other similar videos. Keep watching by clicking on your screen now.